So our group's project was amending the TCLab controller in order to improve controlling with the addition of fans. And we are Joshua Arment, Clarissa Knight, and Jeremy Halverson. So because we were adding fans, we ended up with a multiple input, multiple output controller, and that makes an FOPDT model difficult to use. And so we used MPC Controller instead of a PID controller. So a PID controller optimizes KP, tau p, and theta p, as well as KFF, in order to get an FOPDT model for our system, whereas an MPC controller just uses the physics-based equations in order to optimize our uncertain physical parameters. PID controllers try to minimize error at each time step, whereas an MPC controller predicts estimated future values and tries to minimize the error in the future.
So here's what a schematic looks like. You're probably familiar with the TCLab that you see there with Q1, T1, Q2, and T2. We're running that at the same time as another controller that we hooked up to a second Arduino that you see there. Notice that we had to plug the second Arduino into a 12-volt supply instead of a 9-volt supply in order to get the optimal power to the fans. Both of those actuators, the Q1, Q2, and F1, F2, are plugged into our Python MPC controller, which is running the equations that you see at the bottom of the screen there as its physics-based equations. Now, in order to use these equations, there's a lot of unknown parameters that we needed to solve for. We solved for these unknown parameters using a step test that varied both the heaters and both the fans and measured the temperature outputs, and then minimized the error of the model prediction for the temperature outputs versus the measured temperature outputs. You can see there on the right that we had 14 different parameters that we optimized for, and we then plugged those into our MPC.
As you see with those parameters plugged into our MPC controller, we have demonstrated here the images without the fans and then with the fans. And so you can see we've got better control of the set points, and you can see, for example, at about 50 seconds, the heater 1 is still ramping up to reach the set point, while the temperature for the second set point is maintained constant with the use of the fans. In addition, at 240 seconds, there is a sharper decrease in temperature to reach the set point there compared to being without the fans. These results show that we have a better controller with implementation of the fans. Some future opportunities we have with using this TCLab, we would like to next implement a moving horizon estimation where we can estimate the physical parameters in real time. We also thought it would be cool to add a physical barrier to prevent F1 from affecting heater 2, Q2. In addition, we could add cold reservoirs behind the fans, and this would allow us to reach sub-ambient temperatures.